In this presentation, we're going to have a look at one of the most powerful techniques in object-oriented programming called inheritance. So as an overview, we'll define what inheritance is, and then we'll talk about overriding methods, which is different than overloading methods. We'll finally have a look at some of those access modifiers that we've been avoiding, such as public, private, and protected. We'll talk about how to override the toString method that you've inherited, as well as the equals method, and then do a comparison between the equals method and the double equals sign. And then we'll finish off talking about killing Java dogs and the garbage that it creates internally in memory. So what is inheritance? Inheritance allows one class to take on the properties of another class. And so we have a different relationship now. We have a superclass-subclass relationship, which is also sometimes called a parent-child relationship. And then we also have another term of base and derived classes, depending on the language that you're working in. Now, in Java, we're going to use the keyword extends to express this relationship between classes, and the subclass is going to inherit certain attributes and methods. So you have to be a little bit careful if you're asked what inheritance is to avoid using the inherit word in your definition. Now, there are several benefits of inheritance that you'll see. The first one is that it's good design, and then also we get to reuse a lot of the code without having to rewrite it. So here's an example of a class hierarchy. In each of these rectangles, you can see the definition of a class, or at least the sketch out of a class. So at the top of this hierarchy, we have a class called mammal, and you can see that it has a weight, as well as a method of giving birth. And notice that there's no details here related to mammal, but it doesn't really matter. Now, immediately below that, we have another class called land mammal that has a number of legs. But notice that it inherits from mammal. Now, how do I know that it inherits from mammal? You see this up arrow, and notice that it does go up. That up arrow in this kind of diagramming says that land mammal inherits from mammal. Now, we can continue this on, and you can see that dog is going to inherit from land mammal, and also that it has a Boolean called rabbit here on the inside of dog, and we can continue this on down, creating a chihuahua and also a sheepdog. So the trick question here is, how many attributes does dog have? Well, because of inheritance, it actually has 3. We've inherited num legs from land mammal, and that inherited weight from mammal. So all of that propagates down here into dog. And also of interest is that the dog inherited the give birth method up here from mammal, which was inherited by land mammal. So land mammal is a superclass to dog, but it's a subclass to mammal. And notice also that the dog does have 3 attributes, weight, num legs, and rabid, and we've inherited all of those things all the way up through the hierarchy, all the way from mammal to land mammal down here to dog. So here's an example of what we're talking about. We have a class Java dog here that we've seen a couple of different times. Notice that we have 3 different attributes, Boolean rabid, int weight, and string name, and you can assume that there are other methods there like your accessors and modifiers and constructor. And then also notice that we have this growl method that we've included that prints out grr to the screen. So let's assume that we need to create a poodle class. And since a poodle is a type of Java dog, how can we make the class poodle without rewriting a lot of code? Well, you probably guessed it that we could use inheritance, but does a poodle necessarily growl the same way that a Java dog growls? Probably not. So what we could do is to create this class poodle by extending Java dog like you see here. Okay, we inherit everything that's public from the Java dog except the constructor. And that makes sense because the constructor says Java dog, it doesn't say poodle. So we still have to create a poodle constructor that's even very similar to the Java dog constructor that you've seen previously. Okay, so what just happened? We created a poodle, and it has all of the attributes and all of the methods that are public from the Java dog. The problem is that if I were to create a poodle, like you see right here, my poodle gets a new poodle, and it weighs 3 pounds, and its name is Fluffers. If I were to tell that poodle to growl, it's actually going to print grr, but poodles don't really grr, they yip because they're really small. So how do we overcome this problem? Well, we're going to have to override the method that we've inherited. So if you're not happy with something that you've inherited, then you have to redefine it. That's all that overriding really means. Now, don't confuse this with the term overloading. When you overload a method, it means that a method has the same name as another method, it just has different parameters. This is totally different. This says that you're not happy with something that you've inherited, so you're redefining that method. So here's our better poodle. You can see class poodle still extends Java dog. We've included the constructor here at the top, and then you can also see that we've redefined growl. All I had to do is say void growl and put the parentheses here and redefine that method. And you have to be careful because it still has to contain the exact same method prototype as the one that we inherited, which means that we have to put void growl in a set of parentheses. And then here on the inside, we just redefine it to say yip instead of gur. Okay, with regard to these access keywords, this is kind of levels of protection that you have on your methods, on your classes, and also on your attributes. So we can restrict the access to other classes by putting one of these three things in front of the variable. When you say that something is public, it means that everybody has access to it. Everybody can see it, everybody can manipulate it, and that can potentially be a bad thing. We also have private, and that means that only that class can see it, meaning that it's the only one that is allowed to change it and have access to it. Also, there's something called protected that's used when you're talking about packages, but we're going to skip that for now. So here's an example of something that won't compile. It says it's a bad example. I actually think it's a great example because it shows how private can change the way that we have access to things. So notice that we have class X at the top. There's a private modifier here in front of int myInt, and then you can assume that there's a constructor and other kinds of things that are inside of class X. Now here's something that you can't do. Notice we have public static void main, and then we try to create a new X inside of the driver here. My X gets a new X. That's totally fine, but if we were to try to access one of those private variables inside of X, it won't allow us to do it. So if you were to try to say myX.myInt, this private variable up here, and you tried to assign it the value 42, it's actually not going to compile. It's going to complain and say that you're trying to access something that's marked as private. So how do we overcome this? It's really one of two different ways. We could either make it public, or we could provide accessors and modifiers to allow other classes to see it. And that's typically what's done. Now, why would you want to mark something as being private? Well, first of all, it's for security. This keeps other classes from directly changing the attributes at random. You typically want to encapsulate everything in the class so it's complete just by itself. Also, there's a bit of design here in that it forces the other classes to use these accessors and modifiers, and you can restrict what it is, the values that they try to assign to that attribute, so that if they're outside the bounds of what you intended, you can just restrict it however it is that you want to restrict it. So here's a really useful function, and it's called the toString function, and believe it or not, you inherit the toString function no matter what. Okay, so we can override it when we create our classes. So what happens when we have some code that looks like this? I could say Java dog J1 gets a new Java dog that weighs 21 pounds and its name is Nomad. And if I were to try to directly print out the variable J1 like you see right here, system.out.println J1, what's going to print to the screen? Well, it's going to look something like this, OXFFFED, a whole bunch of garbage, and it's not going to be exactly that. And that's actually the memory address of where J1 is located in terms of memory. So what we can do instead is to override using this toString method to print your object out the way that you like. So here's an example of what that might look like. Again, we've cut out some of the parts of code inside of JavaDog, but you get the idea. So inside of JavaDog, class JavaDog, you can see that we have a toString method that we've overridden. We actually inherited that from a class called object. And notice that it returns a string. So here's your return type, string. The name of the method is toString. That doesn't take anything in as a parameter. And then what we do on the inside of toString is to construct a string that represents what this thing should look like if it's ever printed. In this case, what we'll do is we'll create a string called s, and we'll say that the name is whatever the dog's name is, and then we'll add in additional strings that print out the weight, or just add in the string weight, and the same thing is true for rabbit. And then notice what we do as the last statement. We return that string because we said we would return a string right here in toString. Now, how is this used? If we come down here to main, you can see that we create a Java dog called Bill that weighs 12 pounds, and then if I were to directly print out J1 at this point, system.out.println J1, it's actually going to call the toString method like you see here. So the output of this code is going to be name is Bill, weight is 12, and rabbit is going to be false. Okay, Another thing that we can override is the equals method. Again, you've inherited that from a class called object, whether you like it or not. But there's two ways that we can test for equality. When we use the equals method, it means that they have equivalent information in them. When we use the double equals sign, we're actually testing to see if they are the exact same object in terms of memory. So an example in everyday life is, imagine that you have some twins, and twins usually look the same. They have the same height, they have the same weight, hair color, and everything else. They may even speak the same. So realize that they are not the same person, though. They are two separate people that have equivalent characteristics. Let's see what we're talking about here. We'll do a memory trace, and you can see that in the first line we've created a Java dog J1 and J2. So what's going to happen here is that J1 and J2 are going to point to null. In other words, they're going to be dead dogs. Now in the next line down, I bring J1 to life. I'll say J1 gets a new Java dog, passing it the weight of 5 and the name of Bob. So what's going to happen? Now J1 is going to point to this chunk of memory, and we're going to fill in the information from the constructor. So rabbit is going to be false, weight is going to be 5, and name is going to be Bob. Now if you notice what we do in the next line, we do the same thing with J2, giving it the value 5 and Bob. So if we were to look at this, you can see that they have equivalent information even though they exist in two different locations in memory. So right now, J1 and J2 have equivalent information, so they are dot equals to each other. And so an example of that would be if I said J1 dot equals and I pass it J2, this whole expression right here evaluates to true. However, J1 and J2 don't occupy the same space in memory, so they're not double equals to each other. So if I were to try saying J1 double equals J2, this expression right here actually evaluates to false. You might put it inside of an if statement, let's say. If I have J1 point to J2, you can see I can do that right here. J1 gets J2. I would have something that looks like this in memory, so that J1 and J2 are now referring to the exact same chunk of memory. And when I do this, now J1 and J2 are both double equals and dot equals to each other. However, notice that nobody's pointing to this chunk of memory right here. So the question is, what happens to it? When you have a situation like this and you have a chunk of memory that nobody's referring to anymore, we have something called a piece of garbage. In other words, you've killed this chunk of memory, and a little bit later on you have something called a garbage collector that comes around and cleans up all of the dead pieces of memory. So it's up to us programmers to determine what it means to be equivalent. And so for our Java dog, we could do any number of things. We could say it could be based off of the name or the weight or whether or not the dog is rabid. It's up to us how we want to determine this equivalence. So we could say if the dogs weigh the same, then they're considered to be equivalent dogs. What might that look like? Well, we can override this equals method like we talked about before. Notice that it returns a Boolean, right? And then notice that it also takes in another Java dog to compare itself to. So on the inside of this method, we might say something like this. If the other dog's weight is equal to our weight, then we would return true. Otherwise, we would return false. So then in main, let's say that we're in our driver now, I could say something like this. If J1 dot equals J2, and if their weights are the same, then this would evaluate to true, and then we could do whatever stuff we needed to do. Another trick that might help you is when you're going through a lot of testing and you're working on a class that you know is going to be used by other people, you might want to do something like this. You can include a public static void main inside of your class itself, and then you can bring to life one of the dogs or whatever it is, and then have some other code here that might test out that dog. So the question is, do you really want to do this all the time? It depends on what it is that you're trying to do. As you go through testing, yes, it would make sense that you would do this for every class that you write because it's really good for debugging your code. However, if you have multiple mains, right, because we have a main inside of JavaDog now and we also have a main inside of our driver, how does the system know which one it's supposed to use? And you actually have to manually set that inside of your IDE, but only one can be the entry point of the program. So as a summary, there are a lot of benefits to using inheritance. First of all, it allows us to reuse some pretty good code. So you can imagine we've got really complex calculations or something inside of a class. We can inherit that and then modify it as we need to. Also, this allows for good design so that we can kind of tuck away details where they belong, and we can have this reuse of code that we were talking about across multiple classes. Also realize that, believe it or not, all classes inherit from a class called object, and because that's the case, we inherit something called toString and inherit another method called equals that we can use to test for equivalence. Realize that double equals test for the exact same object in memory, and that it's usually a good idea to override this toString, so if we ever try to print out a variable, it's going to print out something meaningful. Finally, as a debugging technique, you might want to include a main inside of each object that you create, just so you can test it out before you hand it off to some other programmer. So that's it for inheritance. Hopefully you understand a bit more about it, and we'll see you in the next tutorial.